Hello everyone and welcome to another video on the Red Python YouTube channel. In this video, we will discuss secure coding practices and best practices in alignment to ISO 27001 standard. The purpose is to provide you with an overview on the web application security threats. We'll illustrate the top vulnerabilities, we'll see how to mitigate those, and we'll come up with some conclusions. It is good to keep in mind that you are a target. Everyone, every company, every application out there in the wild over the internet is a target for attackers. I'll start with some information security principles. A threat agent is like a hacker or someone who is having a malicious intent to perform something, can interact with our system, such as a web application published over the internet. This application might have some vulnerabilities. Vulnerabilities are weaknesses. Weakness can be in any layer in the web application. We'll discuss that in a while. And the hacker can exploit this vulnerability to cause impact. Impact can range from being simple to critical. Some impact can affect businesses, can bring down businesses. Going next, so where are the current security flaws? Well, it is throughout the software development life cycle. In a nutshell, many people, they don't identify security requirements upfront. They roll up their sleeves and start developing without taking security into considerations. Many people, they create some conceptual designs and logic errors during the coding. If you don't use best practices while coding, you will expose your code into vulnerabilities. When you're not deploying your software properly as well, this is another hole in there. And of course, during the maintenance, such as patching, upgrade, we'll talk about as well release management, change management. These processes, if you have gaps in these processes, of course, you'll be introducing vulnerabilities to your environment. Now, when we talk about web application security, we might mean different things. So you can secure a web application by using a WAF, for example, which acts at the network protocol. So some WAF like act at the application protocol, but here we're just referring to the networking part of it. You can implement firewalls, routers, intrusion detection system, prevention system, etc. So you got the idea. The other layer is operating system. So of course, the website will reside on a web server that is on top of an operating system. You can make sure you're patching your operating system. You can make sure that proper authentication, authorization, encryption is there. Now, going more towards the application itself, we use COTS or commercial off-the-shelf systems, source code, etc. And we don't know actually what is the attack vector or what will these applications introduce to our environment in terms of vulnerability. So we need to make sure that we're using minimal services. We need to make sure that they are configured properly. These components are really patched. We need to take to be careful as well from the application authentication and authorization perspective. Now, the core of this presentation is about custom web applications. Many of us try to reinvent the wheel. We don't use like frameworks. We try to code everything from scratch. This is challenging, of course, but there are some frameworks out there that can help you diminish the attack vector and maybe to say that get rid of many of the mistakes, intentional or unintentional mistake that we do during coding. We need to take care of the architecture. We need to make sure that the application is well architected. Design and code review is a must if you're coding everything from scratch. And I cannot stress more on testing. Before you deploy any application to your production environment, make sure to test. So how bad is it? Well, I have compiled here a couple of statistics from different sources, such as like Watchfire reported 97% of 300 web applications they audited were vulnerable. Trustwave is another company that reported 7 out of 10 web applications they audited were vulnerable. Other reports, they say like more than 90% of web applications are vulnerable. And Gartner says that the 70% of the attacks in the wild are mainly targeting the web application or at the application level. So you can see it is really bad. So so if it is that bad, how come like organizations are still up there and running, functioning, websites are not defaced? Like, so if it is that really bad, why is mainly we're not like feeling that there is really a disaster out there over the internet? Well, because of two main things. Many attackers, they just try to own the website or the application without doing any changes. So it's just like they stay there in a passive mode, monitoring what's happening. This is really hard to detect, but this is the case. On top of that, web applications are not really easy to attack. So it requires more than a script kiddie to come up and hack such web applications. So you'll not like download something on your Kali machine and just press a couple of buttons. No, it needs an expertise. It needs a mix of automation and expertise. So you need a hacker who's expert in his domain, who knows what he's doing. So I can say that if an attacker wants to hack you, they will hack you. The top application level security attacks we'll discuss today are mainly the OWASP top 10. Bits and pieces from here and there. I try to compile the most critical ones. So we'll start with the cross-site scripting. Cross-site scripting, it is an attack that enables attackers to run JavaScript on a victim's browser, as simple as that. So what does that mean? So attacker, they don't try to attack you directly, right? So they exploit your trust in a web application that you use, and they might send you some crafted links. They might insert some code, which is a harmful code, in the database of the application that you're trusting, and the attack starts from there. As I said, the attack typically takes the form of an HTML tag. So it's a crafted link that might be sent to you over the email. On top of that, the website needs to have a text box, or needs to be able to receive some input or feedback from the user, such as text box, forum, for example. So whenever you have a text box that is not properly managed, sanitized, etc., the website might be prone to cross-site scripting attacks. So we have two types. Actually, we have three types, but here we're just discussing two. We have persistent, reflected, and we have the third one is dumb. The persistent, as the name says, the malicious code is there in the database of the application. So whenever you visit the same page over and over again, the same code will trigger, right? So if you're visiting a forum and the code is in the database and the forum is fetching the data from the database, the user will like run the JavaScript. The JavaScript will run whenever the page is visited. The next, or the second type, is reflected. So from the name, the malicious string originates from the victim's request, or it's the crafted message. So let's go into the details here. Before doing that, so why is JavaScript dangerous? So what is dangerous about running JavaScript? JavaScript can steal cookies. So it can steal the cookies from the victim's browser, and cookies have confidential information such as session IDs, roles, etc. This will put the victim at risk. It can log your keystrokes, and it can as well expose the victim to phishing attacks. The victim, the JavaScript might create a phishing or fishy websites that look similar to legit ones, and the victim will fall for that. Now, cross-site scripting, a stored example. So in this example, this is on the right here. This is client 1, which is a malicious user. He goes into a forum on a web page, and he inserts JavaScript in the in one of the boxes, and this will hit directly the database if it's not well sanitized. So he will insert script alert 1 script. So this is just a simple script, JavaScript, to mimic the actual attack. Now this is now in the database, so when client 2 visits the page, the HTML page will be rendered and the script will be run, right? So it will display a pop-up with number 1 there. But instead of this simple JavaScript, a malicious JavaScript can be there that can steal for example, the cookies of a user. So this is the stored example on how the code will look like in the HTML page, right? So in this first example here, the page is accepting comments, so it will fetch the database.last comment, but if the comment from the database is script, it will just display the script there. It will run the script. The reflected example is somehow different, as the attacker will craft a link to the website, and it will be sent to the user. The user will click the link, and the JavaScript will run. So as you can see, the JavaScript will be run on the victim's machine. Victim's machine. And if the code is critical or malicious, it will leak some of the information back to the attacker. So I think you've guessed now that one of the mitigation approaches is to encode the way in where these scripts can be translated by the browser, and maybe the other way is to sanitize and prevent users from initially inserting such commands. So here's an example. We will look at it later on. So the protection, mainly, as I said, it's encoding. Encoding, it means that these special characters need not to be displayed or need not to be interpreted by the browser as they are. Just encode them and convert them into an ASCII mode. This will prevent the browser from running any script. The second protection approach is to validate your input. So it's easy, like, not to accept any input that has such special characters to begin with, right? And it's important to use frameworks rather than coding from scratch, because many frameworks have this protection built in. The next vulnerability, which is very important vulnerability, is injection flows. When we say injection flows, we refer to SQL injection and OS injection. In a nutshell, the idea is that an attacker will trick the web application, and by tricking it, he'll be able to control the database which is running in the backend. So let's see how is that done. For example, we have a web form here that will accept the user ID, and a normal user will just type in a user ID and press on search. This will translate to the following query, right? So select star from users where user ID equal the text from here. So this is the query behind the search button. Pretty straight and simple. Now, a malicious user can use this command instead. So instead of putting a number, he might put 105 : drop table learners, right? And this will translate to the following. Select star from users where user ID equal 105, so it will execute that. There's a colon, and there is another command, drop table learners, right? So if you're running your web application using a privileged account such as SA on SQL Server or sys or sysadmin on many other DBMS, this will delete the table of learners, right? And you don't want to do that. Another approach is to make the query return a true. Like you can use that, which will translate to select star from users where user ID equal 105 or 1 equal 1. So this is a true statement which will return star from users. So it will expose all the data of all the users. So this is just a simple, very, very simple example, because there are automated tools out there that can exploit SQL injection vulnerabilities in the web application in a more deep way. So how to protect against that? SQL injection is still the #1 vulnerability out there on the web. It is important to design and review your codes. Don't accept like input that might compromise your application, and run your application with very minimal commands. I've seen it many times, many applications, the programmers use SA, sysadmin, whatever, and because, they just want to have the application up and running, but this is really serious, and this can compromise your full environment. At the end of the day, if an injection, SQL injection attack is successful, the attacker might or will be able to run remotely some code, and they will be able to compromise all your environment. The third vulnerability I want to talk about is the malicious file inclusion. So many of the web applications out there, they accept some files to be uploaded by the user, such as the picture, their CV, anything, right? And if this file that is being uploaded is malicious, the attacker will have the capability to compromise your server and probably your environment. They can place some executable or shell codes in the application. They might replace session file. They might, sky is the limit if an attacker is able to upload those malicious files on your servers. It is here just like drag and drop, and voila, the file is there on the server. Now, how to protect against that? Well, if possible, do not allow user input. It's easier said than done, but sometimes you really need to take an input from the user. In that case, so only allow uploads to a path outside the web root. So make a directory outside the web root, put the privileges to minimal, and just accept files to be uploaded there, and just accept only certain types of files and not all files, right? Do not accept, like sometimes an application will accept a URL from the user, which points to another application. Just don't accept that, right? If possible, implement sandboxing technology, and as I said earlier, make the privileges minimal on the folder in where you're accepting those files. Scan all the uploaded files. This goes without saying, and set file limits for the files that you accept. Another vulnerability is insecure direct object referencing. So many applications, they expose internal objects and make them accessible through parameters. Internal objects might be files, directories, URL, etc. So if they are not well protected, an attacker might find his way to bypass the controls and expose the data on your servers. A simple example here is the profile ID that is exposed on that site. So an attacker might try to increment this number here, 124. If you don't have the proper controls in place, the attacker will be able to go through all your profiles and expose this data. The protection can be using indirect mapping. So instead of doing like adding +1 to the profiles, you can use indirect mapping. You can use some kind of formula to refer to the next profile, right? It shouldn't be that obvious and pretty straightforward to the attacker. On each reference to a new profile or to a new URL, you need to re-verify the authorization, and you need to re-authorize actually the user, so to make sure that he has access to this data that he's fetching. As well, it's not recommended to expose objects via parameters, so don't use the get method. It is really bad. Now, cross-site request forgery, or as known as CSRF, is a kind of attack that takes advantage of logged on users. So if a user is logged on to an important application, financial application with high privileges, attacker might exploit that. How? For example, like they might send you an email with a simple image. The code behind this image might be like, for example, transferring funds from one account to another, right? So you don't need to re-authenticate if the application is vulnerable, of course, and this transfer will take place. It's as simple as that. So how to protect your applications against CSRF? You need to eliminate all the cross-site scripting vulnerabilities. Again, don't use get. So as you can see here in the previous example, we're using get. Don't allow your application to accept get requests. And for sensitive actions such as transferring money, paying, etc., you just have to re-authenticate or digitally sign the transaction. And I can say more than that. You need to provide an OTP, or you need to authenticate with another approach. Some applications, they have a different password for your transfer rather than your normal password. So you have many techniques there that can prevent and protect against CSRF attacks. Improper handling and information leakage is as simple as it may seem, but this is a very important piece of information that attackers use, right? Many of our applications can like unintentionally leak some configuration information about our application, such as these ones. Like in the first example, it's obvious that we're using a Microsoft Access database, and this is the name of the database. And the second example, it's obvious that we're using SQL, we're using Oracle. So the attacker, knowing this important piece of information, they will tailor their like kill chain or attack approach in order to compromise our environment. How to protect against that? It is simple. I know that while coding, you need to have this information, but once your application is in production, make sure that the messages you're displaying to the users are just short messages that will not reveal much about the application or the infrastructure. Make sure to log this information, which is more detailed, into an internal log file. Make sure not to put any database name, tables, protocols you're using in the error messages. Information leakage is another example. Many applications respond differently to incorrect username and an incorrect password rather than an incorrect password and a correct username. So this piece of information is very important to the attacker. If you enter like a username and a password, some applications might tell you your password is incorrect, please try again. No, so this piece of information says that, okay, your username is correct, now you just have to deal with the password. Again, I advise you guys to ensure that you have a standard response whether the username or password is incorrect, such as your credentials are not correct or your username or password are not correct. So try not to give users more information than they need. Broken authentication or session management. So as you know, HTTP and HTTPS protocols do not provide tracking for user sessions. So ultimately, some vendors come up with their tracking or session tracking techniques. Some people, developers, try to reinvent the wheel by coming up with their own session tracking techniques. This might introduce some vulnerabilities to the code that the attackers might leverage. So as you all know, of course, like session ID, this is very basic, is unique to user. It is generated by the server and the client replies with the session ID just to make sure that his authenticated sessions can be sent as hidden variables or cookies or even in the URL string, which is not a good practice. Session IDs or sessions can be hijacked. Let me show you how. If you're not using HTTPS, it's simple as installing a sniffer on your network, and here you go, you just have the session ID. Any user masquerading your session ID will be able to have the same privileges that you have. So how to protect against stealing your session ID? The developers might or need to make sure that they use random, long, complex session IDs that cannot be guessed. It goes without saying that you need to use HTTPS all the time, right? HTTP is like, it's not secure. It shows the traffic in a clear text, so make sure to use the certificates. Session ID should expire. It should time out after a certain period of time. When you're escalating your privileges, you need to consider to generate a new session ID, and URL query string should not be used to provide session ID. Another web vulnerability is insecure cryptographic storage. Many applications store passwords, credit card information, PII, like these proprietary information. We need to make sure that we're storing this information in a secure fashion in the database. I've seen it many times. Password stored in MD5. Developers think that this is very secure, but actually MD5 hash algorithm is the first thing that attackers use to reverse the hashing of any password. So it's a very simple and straightforward. It's transparent to them. So make sure to store these important piece of information properly in your databases. Use encryption with long keys. Some common mistakes is that people store their passwords, certificates, connection strings in a clear text. They don't use salting. So MD5 is really bad, but MD5 with salting might be a good idea, right? Salting introduces some difficulty, some randomness to the hashing. So it's a good idea to use hashing plus salting. Make sure not to develop your own encryption scheme, because this is a very bad idea, and always make sure you're rotating your encryption keys. How to protect against that? If possible, do not store sensitive information. So if your application is not a PCI DSS or your environment is not a PCI DSS certified, do not store any credit card information. Use cryptographic algorithms with strong keys, and be aware of those transparent encryption solutions, because they're transparent as well to the attacker, just as they're transparent to you. And it's very important to review source codes, because the code, when it's there on the production, it's left without any kind of review. It's very important to at least review it on a yearly basis. Another vulnerability is called XXE, or XML external entity, in where web security vulnerability that allows users to upload some XML data, like malicious XML data, to compromise servers. So what are the effects of XXE attacks? They can They allow the user to retrieve files from your server, to exfiltrate data from your server, and to retrieve data via error messages. So how does this go? You know that there is a standard, they call it DTD, or document type for the XML. And the header is just contains a reference to external entities that define these the way how the XML will look like. So by simply changing this like reference to a simple reference, as you can see here on the screen, an attacker can simply compromise the password file on a Linux machine just by simply uploading an XML file that has this header. So how to protect against that? Just disable the X-include feature on your server. As simple as that. Insecure deserialization is another web vulnerability that is out there. Before talking about deserialization, let's talk about serialization. So I'll go directly to the example here. So serialization is the process of changing an object to another format, such as XML, JSON, etc., that is easily stored. An object here can be an PHP form, for example, so you need to convert it to a stream of bytes in order to store it. The deserialization is the opposite operation, so it's just transferring a stream of bytes or like data in JSON format or XML format to an object. So as you can see, when changing the format from an object to a stream of bytes, if the operation is encrypted, the stream of bytes is well maintained, or the integrity of the stream of bytes is maintained. So when you're doing deserialization, if the stream of bytes is encrypted, mainly the operation is safe. But if the stream of bytes is not encrypted, it is easy for any attacker to change the stream of bytes. Thus, the deserialization operation will be compromised. Right? So how to prevent that? Make sure to encrypt the serialization process. Do not accept serialized objects from unknown or untrusted sources. And you should run your deserialization operation with minimal privileges. The last vulnerability I will discuss in this video is the insufficient logging and monitoring. In many cases, there are some events there we have are auditable, but when a disaster happens, we don't get enough information from the auditable events. So it is very important to make sure that we're auditing the right events, and it's very important to make sure that the messages or the information we're getting from this auditable event actually makes sense. It is important as well to store the logs on a different server that is not accessible to the administrator, just to keep the integrity, preserve the integrity of the logs. So coming to the end of this video, I will share the top 10 risk summaries of the web vulnerabilities. As you can see, the injection attack, the SQL injection attack wins. It's always number one since many years, and the impact is really huge. In summary, guys, a couple of like advices, recommendations. You can always contact me in case you have any inquiry concerning this topic, but it's known that application security starts with architecture and design. Take your time in investing in good architecture and design for your application. Security is not like a thing to worry about later on. If security is not incorporated from day one, you'll have something to worry about later on. Custom code often introduces vulnerabilities. Make sure to reuse trusted code. So do not depend on WAF. I've seen many companies, they depend totally on their WAF, and sometimes the WAF like will not do a good job actually. If there is a good crafted attack, many of those good attackers can bypass the controls of WAF, and if your application is not equipped with good controls, the situation will be difficult, to be honest. Don't reinvent the wheel. don't invent a new thing. Again, use trusted code. Design, and test. It's very important to test. Test with malicious input. Test all the possible vulnerabilities that we have seen in this presentation, right? Test the SQL injection, the cross-site scripting. Now you know how these things work, and you know how the attackers think, so you'll probably be able to prepare your test cases in a proper manner. Okay, I also advise you to follow a security checklist whenever you're putting any application out there in production. Use an application security checklist to make sure that it satisfies your requirement before going live.